The internet is a vast network of interconnected devices, and each device needs a unique address to communicate with others. These addresses are called IP addresses, and they are the foundation of internet communication. The most widely used version of IP addresses is IPv4, which has been in use for several decades. However, IPv4 has a limited address space, and the rapid growth of the internet has led to a critical issue known as IPv4 exhaustion. This means that the number of available IPv4 addresses is dwindling, threatening to limit the internet's ability to connect new devices. The consequences of IPv4 exhaustion are significant. It could lead to slower internet speeds, difficulty accessing websites, and obstacles in connecting new devices like smartphones, laptops, and smart home gadgets. As more people and devices rely on the internet, addressing IPv4 exhaustion is crucial for maintaining a robust and accessible digital landscape. Carrier-grade network address translation, or CGNAT, has emerged as a valuable solution to address IPv4 exhaustion. It is a technology that allows multiple users to share a single public IPv4 address, effectively extending the lifespan of the existing IPv4 address pool. CGNAT functions as an intermediary between a user's device and the wider internet. Instead of assigning a unique public IPv4 address to each device, CGNAT enables Internet Service Providers, ISPs, to assign private IP addresses within a customer's home or network. These private addresses are not directly visible or accessible from the public internet. When a device on a CGNAT network wants to communicate with a server on the internet, CGNAT translates the device's private IP address and port number into a shared public IP address and a different port number. This translation process allows multiple devices on the same CGNAT network to share a single public IP address for their internet communications. To understand how CGNAT works, let's break down the process step by step. Imagine you're at home, connected to the internet through your ISP. Your device, like a laptop, is assigned a private IP address by your router. This private address is unique within your home network but not routable on the public internet. When you want to access a website, your device sends a request which is first received by your router. Your router then passes this request to your ISP's network. Here, the CGNAT device comes into play. The CGNAT device maintains a table that maps your device's private IP address and port number to a public IP address and a unique port number. It translates the source IP address and port number in your request packet to the shared public IP address and a different port number. Your request, now carrying the shared public IP address, is sent to the destination server on the internet. The server on the internet receives the request and sends a response back to the shared public IP address and the assigned port number. The CGNAT device receives the response, uses its translation table to identify which device on its network the response is intended for, and forwards the response to the correct device based on the original private IP address and port number. Section 4. Benefits and drawbacks of CGNAT, a balanced view. CGNAT offers several advantages, making it an attractive solution for ISPs and, by extension, internet users. First and foremost, it significantly extends the lifespan of IPv4 addresses, delaying the impact of IPv4 exhaustion. This means more time for a smoother transition to IPv6, the next-generation internet protocol. CGNAT also offers cost savings for ISPs. By sharing a single public IP address among multiple users, ISPs can reduce their need to acquire new public IP addresses, which can be expensive. However, like any technology, CGNAT also comes with its share of drawbacks. One concern is that it can introduce complexities in network troubleshooting. Identifying the source of a network issue can become more challenging when multiple devices share a single public IP address. Another potential drawback is the impact on applications that rely on peer-to-peer communication, such as online gaming or video conferencing. These applications often require direct connections between devices, which CGNAT can complicate. Section 5. The future of internet connectivity, beyond CGNAT. While CGNAT provides a valuable solution to the challenges posed by IPv4 exhaustion, it is not a permanent fix. The long-term solution lies in the widespread adoption of IPv6. IPv6 offers a vastly larger address space than IPv4, effectively eliminating the risk of address exhaustion. Unlike CGNAT, which introduces complexities in network address translation, IPv6 allows for direct communication between devices. simplifying network configurations and potentially improving performance. As the world transitions to IPv6, the reliance on CGNAT is expected to diminish. The future of internet connectivity is one where every device can have a unique, globally routable IP address, enabling seamless and secure communication. Understanding the role of CGNAT in the current internet landscape and the importance of IPv6 adoption is crucial for navigating the evolving digital world.